Okay, so basically, what we're going to do is I'm gonna just go each section. I'm gonna describe like what the concept is. I'll do a question with just numbers, and I'll do a question with an equation. I am making these up as I go, so if there's fractions or something, that's unintentional. Okay. So first thing, if you know this point here and this point here is in the middle, or these are midpoints effectively, then if you connect the line in between them, that's the mid segment. And the concept is the two midpoints make a mid segment, and this middle line, in this case, it's going to be BD. This middle line is going to be half the size as is the line across of it, of AE. So in this case, you could say 2BD is equal to AE. So I will say, let's draw something with the A, B, D, E, F.
It's not, okay. Here, okay. BD? No, I know how to do it. I know how to do it. How are you gonna Okay. So no, I know how to do it too. I know how to do it too. It's like BD is equal to
So
280 and it's also equal to 2AE. No, but how is he gonna ask that?
So I'm gonna. I understand. Wait.
Right here. Okay.
Yeah, I get it.
Yes. So I'm gonna say something like line AB. What is that congruent to? And I'll leave two blanks on purpose to show there's two.
And wait, is it? Can it be two?
Oh, there's two B's. My bad. Let's call that F.
Is it BD?
No.
Wait. Well.
AB is this one.
Well, okay. Well, first there was another.
yes, my fault.
Okay.
DE? No.
BC.
BF.
BC and DF.
Oh, wait, what?
Because it's this one, so it goes this way. Parallel.
I don't
Okay.
get it.
Well, you could check out the other lesson.
Well, you
then.
can just use the lines.
Yes. Well, I'm not writing the lines. I'm just showing you.
But how are you supposed to know you don't like doing it?
Because if I say these are midpoints, then you know this must be a mid-segment, and thus all those things are true. Okay. So if I ask you, hey, BD is 7. What's AE? It's going to be twice as much, so that's going to be 14. And let's say I said BF equals 3x plus 4. And let's say I made CE 7x minus 5.
How did we figure that
So you do.
I'm giving you this.
You do 2 times 3x plus 4 equals 7x minus 5.
Good. So the BF, the small piece in here, the inside piece, you're going to double it. So 3x plus 4 is going to equal the long piece over here, which is CE. So 7x minus 5. 6x plus 8 equals 7x minus 5. Quick algebra. X equals 13. All right. In 5.2, we talked about perpendicular bisectors. We did 5.2 and 5.3 on the same day, just as a reference. So 5.2 is perpendicular bisectors. Basically, the rule of this one is, let's make a triangle.
Are you doing the ones from the packet?
No, I'm just making them up.
Oh, that's.
Nope.
That's not.
Well, literally, the package has the answer already, so I'm not.
Yeah, but what if I want to know how you do it?
You could ask.
Oh, that's really smart.
So, the concept of the rule is if you know this is perpendicular and that it bisects, so it cuts it in half, you could conclude that this is equal to this.
They share,
So the sides, particularly you could do the sides. You could also figure out the angles because it's big.
No.
Not at all.
Last chapter.
That's what I thought. That's what I thought.
So-
I just heard you say angles and sides.
So with that in mind, if I know, let's say this is 3, then I know this one's also 3. And if I said this is 2x plus 7, and I said this is 4x minus 5,
And then you do the solving.
these are equal to each other, so you set them equal to each other. So 2x plus 7 equals 4x minus 5. 2x equals 12,
X equals 6.
x equals 6. Reminder, if I do ask you, let's say, find AB, what do you do after you find 6? You plug it into the equation. In this case, it's equal. You could technically plug it in either
Why
one.
are we plugging it in?
If I ask for AB.
Oh, I see.
So just be careful of that. Just don't forget that. I don't think you should because I usually leave a blank for X and then I leave a blank for
Wait,
the
you
answer.
also read it like that?
No, I mean there's a little blank that you fill in and then that's
Can I
where
just
you're.
write 3 because I already know it's 3? No, because it says right there that it's 3.
It's not 3. No, that's a separate example. I apologize.
Oh, okay.
Yeah.
Okay.
Yeah, I would not give you this just equals 3 because that kind of eliminates the question.
Well, you're doing like 5 different problems on one thing.
Yeah, you're right. You're right.
Well, if you just don't be confused, then
All right. The next one is angle bisector. So let's say if you had some angle like this. You know for a fact that, let's say this middle line bisects the angle if you go perpendicular from that angle, so the legs of the angle. So perpendicular means it's 90 degrees. And I know these are equal to each other. So if I know this, then I can conclude that this line is a bisector, which means this angle equals this angle.
Wait, you know that it's perpendicular at 90 degrees?
You need to know that it's perpendicular, like the line from the leg of the angle is perpendicular, and if they hit the same point. If you know the sides are equal, that means the angles are equal, and if you know the angles are equal, the sides are equal. Okay. With that in mind, so let's say if I ask you A, B, C, D. If I say this is 41 degrees, if I ask you what is CBD, angle CBD, that would be 41. But if I ask you for angle ABD,
that would be 880. And then just double it.
yeah, 82. So just be careful, make sure you read the angle correctly. And then pretend if it was like an equation, if this was 2x plus 1, 3x minus 5, set them equal to each other, and solve from there. X equals 6.
Oh, because the bisectors are equal to.
Yeah. You could conclude they're bisecting. I either have to show you they're both 41, or I put tick marks or something like that. I'm not tricking you in the sense like, haha, this question was actually not solvable. I won't do anything like that. So they don't allow me to do anything like that.
Oh, wait, the line AC and CD both equal.
Yeah. AC, well, that's not, let's say if A was here, sure. A and AC and AD would be equal. All right. 5.4 is the centroid. I think in our class, period 4, I think we did altitudes. You don't have to worry about that. That's not a big deal.
Is an altitude.
Perfect. You don't have to worry about it,
Like
okay?
with the mountains?
Somewhat related, yeah. All right.
Ow. Sorry, I'm sorry. I need to stop hitting you.
7, 6, 9.
Remember yesterday when I was like,
These two are
All right.
so
So, a median, what the heck? A median is when a point in the middle of the line,
Oh, wait, what is this one?
this is going to be 5.4, which is centroids and stuff. So a median is when a point from the middle line goes to the corner opposite of it. So these are equal.
oh, we did
It was a
this.
median?
So then the angles to the big angle is a small.
That one is
side.
that one and everything.
Small.
This one's equal.
Wait, what's a median?
And then
A
that
median
one-
is from the side. It's the middle of the side, so the midpoint to the other corner, to the opposite
Wait,
corner.
I
I
thought
should
a
say.
median. Okay. Never mind.
A mid segment also uses the midpoint.
No,
So.
just because median was a thing last year, but then I remembered that that was last year.
This should all line up correctly. So,
Wait, from midpoint to side?
yeah, midpoint to the corner, I guess you could say, or vertex even.
It was not the
They're all supposed to crisscross at one section, so sorry, my drawing sucks. But that being said, Let's put some letters: A, B, C, D, E, F, H.
Wait.
So in that case, the relationships here is, first off, the sides, the outsides, they're all they're midpoints, so they're all bisected. So you know, like BC should equal AB, AF should equal EFE, and so forth. In this scenario, if you have, let's say, we'll just take one median at a time, or not median. Yeah, it's a median. So let's take this median, BE. BE being the whole thing is equal to the two pieces together, BH plus HE. That's pretty obvious, though. That's segment addition postulate, actually.
Oh, yeah.
Yeah, yeah.
I have a question later.
Sure.
Well, no, I have it now. Can I ask it later?
Yes.
Can you remind me?
Sure.
Of
So BH, the one that hits the side of the triangle, is always 1/3 of the big thing. So BH, in this case, is 1/3 of BE. So in this scenario, I could say that, let's say BH is 1/3. That means I have to multiply BH by 3 in order to match the big thing, BE. The one that hits the corner is 2/3. So if you want to think of it like that, it's 2/3 of BE equals HE. So which means if you want to make this a little bit nicer, you can multiply both sides by 3. So 3 HEs make 2 BEs. This is like a really annoying setup, so just be careful for that. Remember, 3 HEs, because it's 2/3, equals 2 BE. So I would start off like this, and if you don't want to deal with fractions, just multiply both sides by 3. But you can technically just do it with fractions. And then the last relationship, since this is 2/3 and this is 1/3, 1/3 is half of 2/3. So I could say you need 2 BHs to make 1 HE.
this makes my brain hurt.
You got to do the setup at
Wait,
least.
do you know, what do you mean 3BH equals PE? Oh, because 1/3, yeah.
Okay. So with that in mind, let's say if I said B E equals 12. Well, I can find BH by doing 1/3 of 12. So BH would be 4. And then I can either do 2/3 of 12 or just double 4. So I can find HE by doubling it. B.
Wait, B equals 12 and B equals 4?
I'm sorry, BH equals 4. HE is 8.
I'm confused. Okay.
What about it?
Sorry.
What about it?
No, sorry. I'm confused on what I'm doing, but we'll talk about it later.
Cool.
Oh, shoot. I forgot that.
Let's say this one. Let's say CF. Oh, I can't. That's super.
That be used as evidence?
If you do stab her, yeah.
Or could that be like...
Especially if you said it wasn't me. And then you said, I would have never said that thing like that. And then, all right. Let's say if I told you CF was 4x plus 3. Oh, the 2/3 one is always hitting the corner, while the 1/3 one is always hitting the side. So like CH, let's say CH is x minus x plus
Hitting the quarter is 2/3. Oh wait, so for CF,
10.
CH would be 2/3.
CH would be 2/3 of CF.
They're all hitting the corner.
So you could set it up like this:
Oh, those
2/3,
So like
4x plus 3,
CH,
which is CH or CF.
right?
Mm-hmm.
Word. Word.
So CF is going to equal just CH, which is x plus 10. But if you distribute the fraction, that'd be really annoying. So you could just multiply both sides by 3. So it's going to be 2 4x plus 3 equals 3x plus 10. This would be like the hardest setup, but usually it's either a third or a half, okay?
So 8x plus 6.
8x plus 6 equals 3x plus 30. 5x, oh, I messed up a little bit, equals 24. X equals 4.8. Divided by 5 on both sides.
Shut up. No one cares. No, oh my goodness. No. That was not meant for you. Oh, no. That was not meant for you. I was talking to Melanie because she was laughing. Wait, no, Mr. Tobler, that was not directed at you.
I didn't figure it was directed at me,
good.
don't worry.
Oh, that's so bad.
But in the video, it might sound like that.
No,
So,
no,
if it shows up.
No cruising.
Ah!
Alright.
Great job, essentially.
5.5 inequalities in triangles. So in general, a triangle, if you're talking about a triangle, if your two sides is too short to make a triangle with the third side, that's not going to be useful. So that cannot form a triangle. So if we said A, B, C, assuming like A is the smallest, B is the middle, C is the biggest.
Oh, I know this one.
So C
The two small ones you add them together has to be bigger.
has to be smaller than the two added together. Or another way you can think of it, A plus B, the two small ones, have to be bigger than the largest one, which is C. Okay? It has to be larger. Equal to does not work. If you had an equal to, what would occur, let's say these two are equal. Yeah, the problem would be like as soon as you try to open it up, like to make a triangle, it'll like have a little bit of like a blank, like right here, like a little gap.
Because then you open it and it makes it bigger.
Kind of, yeah. So with that in mind, if I said, hey, does 4, 5, 6 make a triangle? Well, 4 plus 5 is bigger than 6, so yeah. If I ask you, what's the range between 4 and 5? So what's the smallest thing it could be and the biggest thing it could be? You could do 5 minus 4, which would be the smallest thing, 1, is less than x, which is less than, and then 5 plus 4, which is 9.
I have to write it that way.
Yes.
Oh, I can't just write.
No, you can't just write 1, 9, because I would think that's 1 minus 9.
No, can I write?
Use words.
Oh yeah, no, you're right. That's what I was doing.
You know what? No, you just gotta have to put the letters and numbers. Oh, and then in triangles,
That's
yeah.
I thought it was gonna go. Oh my God, it's not a triangle.
Okay, in a triangle, let's say if I know the angles in this situation, I could tell which one is the biggest side and the smallest side by the opposite angles. So if I were to ask to list it from biggest to smallest, or let's say smallest from biggest, AC would be the smallest because it's the one across the 30. Yes, I know it doesn't look the smallest, but let's use imagination. AC, which is less than this one, which is CB.
We'll have C's and L's for this because it makes it super confusing.
I'll keep that in mind.
So confusing, let's see.
Which is less than or equal to A.
L can look like
No,
a carrot.
B. That's fair.
The
That's fair.
angle, when you have to put the angle in order, and then like you do
Yeah.
like a million triangles.
For the angle ones, you could just put, and let's say it was the angle ones, you could just put B is less than A, which is less than C. I won't go crazy for the angle symbol because I know it's annoying. It also works in reverse, so the biggest side is across the biggest angle. Five point six.
Why is she on the floor? Okay, kill her.
Sorry to draw, but so 5.6 is hinge theorem. Think of like the hinge of the door. And that's going to be, if this is let's say 55 degrees, and this is 40 degrees. Let's call this A, B, C, D, E, F. In this question, because these sides are the same, and I know the angles in between same, what I'm going to do is I'll probably just have something like EF, and I'll leave a blank in the middle, BC.
Oh.
So you just tell me which one's bigger or smaller. In this case, EF is bigger than BC. It works with angles. Is there anything else with hidden zero?
Which angle's bigger or which side?
Which angle's bigger? Well, because the angle's bigger, the side is bigger. I should say it like that, okay? Because the angle's bigger, the side is bigger.
That's like a
Sit down.
sitcom where there's no audio.
Isn't that the point? Whatever.
Wait,
Ziva, you had a question earlier, right? Oh.
yeah. Oh.
No.
Ziva, can you unlock the door?
I don't think I can.
You can do that. Do it, please.
No, because I think if I unlock the door, Melanie comes in here, I cannot be held responsible for my actions.
You're recorded.
That's why I'm saying the recording.
But
the recording shows that I'm going out of my way to not.
You're denying somebody her
She's
education.
going out of her way
It's not recording ever.
Wait, Miss Total.
Yes.
That means that EF would be larger.
Yes, because it has the bigger angle. Ziva, let her in now. I'm sorry.
She's scared of something out there. What is it? Wait, who is it? Wait.
I thought you were going to open the door, though. Just open the door. This is all recorded, yes. Anyway, that's our video. Ziva, do you have a question? I guess not. All right. Good luck on the test.